My name is Santosh Kumar Kotakonda. I work as a Vice President Lead Software Engineer at world's leading financial domain. Today I'll be presenting my work on a novel approach to automated performance testing for web applications using Jenkins, JMeter and BlazeMeter. As you all know, in financial domain, we deal with trillions of transactions every day. So the applications underneath requires accelerated CI/CD pipelines, meaning continuous integration and continuous delivery. But these introduces risks. Financial services operates under extreme service level objectives. Example like these applications has to be available above 99.95% every time. A single performance regression reaching production can cost millions of dollars per hour in downtime alone. So here we see two gaps. One is existing automated tests cannot accurately replicate high-stake stochastic financial traffic. Whereas gap 2, the raw metrics like latency and error rates are never translated into quantifiable business impacts. So here we introduced CFPA methodology called Continuous Financial Performance Assurance, which is a unified framework that integrates realistic load design, cloud scale execution, and automated pipelines. So this methodology gives high fidelity load modeling using Apache JMeter with stochastic scripting and cloud scaling execution using BlazeMeter, which in turn distribute millions of virtual users. And you can programmatically set up the quality gates using Jenkins enforcing service level objective driven build promotion. And finally, we can translate service level indicator to key performance indicator where you can map latency to direct user conversion loss. So with JMeter in place, we can achieve modular architecture where you can parameterize event environment abstracted test plans that evolves with application changes. And also you can do a dynamic data handling, like you can have all your data into a CVS file where you can save user identities, session correlations, and CSRF tokens, ensuring stateful, realistic user journey. Modeling, replicating market open and close auction spikes, exposing query limits and concurrency bottlenecks. So the cloud execution and Jenkins orchestration. So the three components like JMeter, BlazeMeter, and Jenkins, we can orchestrate in such a way that uh, you can use the JMeter to create your test plans part of your .jmx files, and you can use BlazeMeter once you have your test plan set up. You can run in you can provision millions of virtual users at the same time using BlazeMeter, which gives you an open API and a plugin for Jenkins. So at the end, once you have BlazeMeter set up, and you can integrate that into Jenkins, which is a build promotion and artifact management tool that gives declarative pipeline enforcing quality gates on BlazeMeter results. Quality gates plays a key role when promoting your builds to production. So these are not arbitrary checks, they are mathematically derived SLO thresholds, meaning application should have 95% all your requests should have a response within 500 milliseconds, and the application should be available all the time, like above 99.95%, and throughput like transactions per second should include a baseline transactions per second plus 10% buffer. So the correlation between service level indicator to key performance indicator. So the key performance indicator loss is a function of service level indicator latency, meaning, let's take an example. When a page loads within 2.4 seconds, 1.9% of users can complete their work. And the same page, if it loads at 3.3 seconds, then there will be a loss in user completing their work. So every millisecond has a dollar value, making the performance report a predictive financial accounting indicator. So when quality gates mapping SLIs to SLO to KPI mapping, so we take three service level indicators: the P95, transaction success rate, and transaction throughput. If P95 fails 500 millisecond threshold, then we consider the quality gate as a failed build, and which in turn a loss of 2.5% transaction conversion rate. When it comes to transaction success rate, when availability is less than 99.95%, then again we'll consider the build as failed build and an estimated downtime cost and increased customer churn rate. When it comes to transaction throughput, it has to sustain the base transaction per second plus a 10% buffer. If the system is not sustained for these metrics, then we consider the quality gate as a failed build, and there will be a loss of potential transaction volume and revenue capacity. So, so the CFPA methodology is designed to fail fast and fix fast. So the regression blocks before they reach to production, which in turn we can save millions of dollars. And quantified risk. Every quality gate fails include a projected dollar exposure. So if you see this graph, here we have a local JMeter where you can, based on your system capacity, you can provision only few virtual users at a time. But in BlazeMeter, a cloud solution where you can provision millions of users with a distributed environment. Conclusion. So our CFPA transforms performance testing from a reactive QA test steps into a proactive financial risk management capability embedded directly into your CI/CD pipeline. So our near-term plan is to include machine learning capability to enable quality gate threshold that respond dynamically to market volatility and historical performance variance. And in long term, we want to map resource utilization metrics to infrastructure cost KPI, predicting cloud overbuilding from insufficient scaling. So our strategic vision should be every performance test becomes a predictive financial accounting event, enabling banks to quantify and reduce monetary risk from accelerated delivery. Thank you for your attention.